Our next section is graphing the sine and cosine functions. So how do we graph any function usually, right? We make table of values for x and y values, and then we plot those points on the graph grid. So let's say for y is equal to sine of x is the function. I have this table of values. I have started x from 0 and went up to 2 pi. So why do you think that is? As we learned in last section that our sine function is a periodic function. That means after every 2 pi it repeats its behavior. So if we can draw the graph from 0 to 2 pi, we can just extend that further, right? From 2 pi to 4 pi and 4 pi to 6 pi and so on. It will be same graph because it's periodic, it repeats itself. So let's find the values of all these points. At x0, sine of 0 is 0, so the point will be 0, 0. Reminder, x here all are in radians. I'm taking the x values in radians. At pi by 6, that is 30 degrees, sine of pi by 6 is half. So the point is pi by 6 half. At pi by 2, sine is 1. So the value will be pi by 2, 1. That will be the point we will plot in the grid. At 5 pi by 6, the sine value is 5 pi by 6. The reference angle is again pi by 6, so it will be again half. So the point is pi by 2, 5 pi by 6 half. At pi, the sine value would be 0. So we have pi, 0. At 7 pi by 6, it will be the third quadrant. We will have negative half. 7 pi by 6, negative half. At 3 pi by 2, that is the negative y-axis, sine value would be negative 1. So 3 pi by 2, negative 1. 11 pi by 6 value will be negative half, and at 2 pi the value of sine would be 0. So I have some points. I have to plot them on my grid. That's how we plot the graph of anything. So let's say we have these points at 0. This is my x-axis and y-axis intersection. So this is 0. X is 0 here. Y value is also 0. So this is my point. At pi by 6 somewhere value is half. So here. At pi by 2 sine function is 1. At 5 pi by 6 the value is half again. At pi it is 0. At 7 pi by 6 it's negative half. At 3 pi by 2 it's negative 1. At 11 pi by 6 it's negative half. And at 2 pi it is 0. So I plotted all those points. I can draw a curve through here smooth as we can, and that would be the graph of sine function. So this is called sine functions graph. This is also called sine wave. It has a lot of applications in physics and other sciences. So this is a one period of the sine wave. One period is from 0 to 2 pi. Why did we just plot it from 0 to 2 pi? That we can extend. So we can extend it this way and we can extend it this way. It keeps on going from left to right with the same symmetry in the same curve. The highest it goes is to 1, the lowest it goes is to negative 1. So the range of the sine function would be from negative 1 to 1. So let's see all the properties of sine functions which we see from the graph. The domain is all x values, right? Sine functions is defined for all x values. That means the domain is negative infinity to infinity. So the graph of this function keeps on going from left to right, left negative infinity to positive infinity. The range is y value, right? What is y value of this function? For y value, it's not going above negative 1. So it is starting from negative 1, that is the lowest, and the highest it goes is to 1. Sine function is a odd function which is symmetric with the graph with respect to the origin. Sine function is an odd function. We remember that. We did that in the last section because sine of negative x is negative sine x. So sine is an odd function. It is symmetric with respect to origin. If you notice this graph, this is origin here 0, 0. This graph is symmetric with respect to origin. So the sine function is odd and it is symmetric with respect to origin. Sine function is periodic with a period of 2 pi. The x-intercept. X-intercept is what? Where the graph meets x-axis. At what points do we notice the graph meets x-axis? So if you notice, the graph meets x-axis at x equal to 0, at x equal to pi, x equal to 2 pi, x equal to 3 pi, and so on. And similarly, on the negative side, it will meet x-axis at x equal to negative pi, negative 2 pi, and so on. So what are the x-intercept? Negative 2 pi, negative pi, keep on going to the left like that, 0, pi, 2 pi, and so on. Y-intercept, where the graph meets y-axis. The graph meets y-axis at only one point, which is origins, right? So x equal to 0. The y-intercept is at the point 0, 0. The maximum value of the sine function is 1. It does not take more than 1 and occurs at where? Where x is equal to pi by 2 or x is equal to 5 pi by 2 or x is equal to 9 pi by 2 and so on. On the negative side also it will have that value that will be at negative 5 pi by 2 and so on. And where does the minimum occur? Minimum occurred in this case at 3 pi by 2, but because it's periodic, you can keep on adding 2 pi to this, and that will be at 7 pi by 2, 11 pi by 2, 15 pi by 2, and so on. You can subtract 2 pi from here, and it will be the same value. So that will be negative pi by 2, and so on the left. So minimum value occurs at these particular points. Minimum value is how much? Negative 1. The maximum value is how much? 1 for the sine function. So now we know the basic sine functions graph. What if we have the graph of y is equal to negative 2 times sine of 2x? So we have this function negative 2 sine of 2x. The basic function here is sine of x, right? What are the transformations? First is this negative sign. Negative sign does what? Y is changing to negative y, meaning you have the graph reflected across x-axis. Okay. So original sine graph was starting from 0. This will also start from 0. But instead of going up, it will go down and the graph will look like this, right? Now, that wave is reflected because of this negative sign. Now, it's also being multiplied with this 2. Y is multiplied with double. That means, so y is changing to 2y. That means it will be extended vertically, right? So, that means here this is starting from, instead of this lowest point, it will become negative 2. Here, at 0, it will stay 0. But instead of 1, it will become 2. So, these are the points we will have. So because of this 2 multiplication, our wave is vertically stretched. That is the next transformation. The last one here inside, x is also being multiplied by 2x, right? So let's look at that. X is being changing to 2x. That means the graph will be compressed horizontally, horizontal compression by a factor of half. What does that mean? That means whatever is happening at pi by 2 now will happen at pi by 4. So at this point it will be negative 2. Whatever is happening at pi will happen at pi by 2, which is 0. So we have the graph looks like at 3 pi by 2 it will hit 2 and then at pi it will be at 0. So this would be your graph. Instead of your period of 2 pi, the period will just become pi. So the final graph of negative 2 sine 2x would look something like that. You can use the calculator also to check that. So if you want to graph this on our calculator, the first thing we need to check, because whenever the function is given like this, x is in radians. So make sure to check the mod and the radians should be selected. So if it is not, like in this my calculator degrees is selected, I have to select radians. Now it's highlighting, quit from here. In y, you can write the given function, which is negative 2 sine of 2x. So that is my function. If I graph it, I see a wave very small. I can change the window a little bit if I want to see more prominently. The x value I want to see, the y value, maximum value I want to see is from negative 4 maybe to 4, and x value I want to see until, say I want to see 2 periods. So 2 pi, negative 2 pi to 2 pi. Let's see the graph now. Now let's see, what did we do? We said at 0 the graph would be 0, which is true. At 2 pi, so until 2 pi, 2 periods are finished, right? So you see, up we made the first only 1 period until pi. The graph is similar. You can always check your answer from the calculator.